Welcome, Algebra students, to Chapter 8. Today we're going to introduce adding and subtracting polynomials and talk about what is a polynomial. So let's go ahead and get started. So the first thing we should do before we get into polynomials is talk about a monomial. So if you see the base of the word, it says mono. So mono is a prefix that means one. So let me write that, one. So if we're talking about a monomial, we're talking about a polynomial with only one term. I'll do that, with only one term. Now, what does it mean to have only one term? Well, an example could be the number 3. Or you could have 3x. If you have 3 times x, as long as it's multiplication, you're fine. That's a monomial. You could have something like 4x squared. That's a monomial. So anything that has just multiplication in it is a monomial. It's one term. It's not separate. There's no addition or subtraction in there. Okay, there's no plus or minus. So these are all one-term monomials. Now, when we're talking about a polynomial, poly is a prefix that means many. So let me write that down. So this means many. So you might hear poly, and especially in science class, and you might see it in other terms as well. Like a polygon in math is a shape with more than three sides, so it has many sides. So polynomial has multiple terms, and its degree, you can classify polynomials by its degree, and its degree is the highest exponent in the polynomial. Some conditions, polynomial. I missed some letters, hold on. There we go. Polynomial. Some things you need to understand about a polynomial is, one, the bases of all the terms must be real numbers, so it must be a real number. And then the exponent must be a positive integer. Okay, including, it could be 0, which would give you 1, but it needs to be a positive integer. So an example of ones that are not, you could have x to the 1/2. That's the same thing as the square root of x. So there's no square roots with polynomials. Also negative exponents. So let's say 2x to the negative 1. That's the same thing as 2 over x. So if you have any terms in the denominator with the variable in the denominator, that's no good. Or if you have any variables that are inside a radical, that's no good. Now, it's not to say you can't have fractions. You could have 1 over x, and that's a polynomial. Not 1 over x. 1/2 times x, and that's a polynomial. You just can't have the degree right here, the power that it's raised by, be something that's a fraction or a negative number. Okay? Now, we already talked about some monomials, so let's go ahead and talk about them a little bit further. So here we have, these are all monomials right here. These are all monomials. Okay, and we already decided, based on the definition of a polynomial, is that these have to be positive integers. So the coefficients are the numbers that are in front of your variable. So the coefficient of x to the 9th is going to be 12. Now, what is the degree? The degree is the highest power of the exponent. That's in the polynomial. In this case, monomial, so we're only looking at one term, so the degree is 9. It's a 9th degree monomial. Here we have 3x, so the coefficient is 3. Now, what is the degree here? It doesn't look like there's anything, so the temptation is to write 0, but that'd be wrong. Instead, remember that there's an implied 1 there, so this is a 1st degree monomial. Then we have -6. So -6 is the coefficient. Now, what about degree? It doesn't look like there is a variable there. However, if we have x to the 0 power, that's the same thing as multiplying -6 times 1. So technically, this is a 0 degree. I'll leave this in green just because it's kind of a particular rule. But this is a 0 degree polynomial. When you just see a constant, that's when it's 0 degree. And like we said earlier, we can have fractions as long as the variable is not in the fraction. So here we see that the coefficient, it doesn't look like it has a coefficient, but it is 1/3, because 1/3 times x squared is going to give you x squared over 3. So the coefficient is 1/3. I don't know why I chose purple all of a sudden. Let me stick to red. So we have 1/3, and then the degree is 2, because it's x to the second power. So that's kind of some clarification on some of the monomials and what it means to have a degree and what the coefficients can look like. Now let's talk about polynomial types. So we already talked about one of the different types. We talked about monomials. So we could have 2 as a monomial, and that would be a degree of 0. We could also have 2x to the 7th. So the degree here would be 7, just because that's the highest degree of the variable in the monomial. Let's list some others. So we could have a binomial. Now, this has a different prefix. This prefix is bi. Bicycle means 2. So that means 2 terms. What does that look like? This is a very important part. So what this can look like is it can look like x squared minus 7. Now, there's 2 terms now. We have an x squared and we have a 7. Remember that there's an implied, let me change it to light green. Remember there's an implied x to the 0. So how do you pick what is the power, what is the degree when there's 2 different powers here? You choose the highest power. So the highest power is 2. So this is a second degree binomial. So this is a polynomial. This is a specific type of polynomial, which is a binomial. We'd have another one like negative 2x to the 7th plus x cubed over 4. Need to give myself a little bit more room. X cubed over 4. So the highest power, of course, is 7. So this is a 7th degree binomial. And there's only 2 terms. That's why it's a binomial. So let's think about the natural progression here. We have binomial, we have monomial, so trinomial. And then, of course, we can have 4 terms, 5 terms, 6 terms. But this obviously means triceratops, tricycle. I can't think of anything else at the trident. We're talking about 3 different terms. So we could have x squared plus x minus 1. This would be a second degree trinomial. We could have negative 17 x to the 5th plus 1/4 x to the 4th plus, obviously I'm just coming up with these on the spot, plus 2x, and that's just 2x. So this would be a 5th degree because that's the highest power. Now, you generally want to write them in descending order. So you want to put your highest powers on the left and your lowest powers on the right. So that generally means the constants are going to be all the way to the right and your highest powers are going to be all the way to the left. That's called standard form. So make sure you write your answers in standard form. So now that we got the basics, let's go over some examples. It says find the degree of each polynomial. So this part's pretty easy. We're just going to be looking at the different polynomials here and looking for the biggest exponent. So here we see a 4. So this is going to be, let's change to blue. This is going to be a 4th degree. Here we have, pardon me, here we have 3 different terms, 3 different exponents. We have 5, we have 3, and don't forget there's an implied 1 there. But of course we go with the highest, which is 5th degree. Okay, here it doesn't look like there's 1. Of course there is 1. We already talked about how there is an implied x to the 0. So this is a 0 degree. Anytime you just see a constant, this is a 0 degree polynomial. This one's a monomial. This one up here, this is a trinomial. And the reason why I know is because there's 3 terms. So this is a monomial, this is a monomial, and here we have another trinomial. So what's the highest power? Now this one's tricking you because it's not written in standard form, but here we have a 7. So this is a 7th degree. 7th, whoops, not 17th. 7th degree. Okay, now we're going to talk about adding and subtracting polynomials. So let's start with adding. We're going to write in standard form, so that means biggest degree to lowest degree. So what we need to do here is we need to kind of decide which ones are like terms. You can only combine the terms that have the same variable with the same power. So here we have an x squared, and we're going to include the 3 in there, okay? The 3 goes along with it. It's like his little partner in crime. Here we have another x squared, and it has a negative 5. So we can combine those two. Let's think about what other ones we can combine. We have an x, so we're going to include the negative 4 there, and we have a negative 2x, and then we have a constant 10 and a constant 3. So we're going to combine 3x squared minus 5x squared minus 4x minus 2x, and then plus 10 and plus 3. A question I get a lot is, okay, what do we do with this positive here because there's parentheses over here? If it's positive and then there's parentheses, we essentially just can remove the parentheses. We don't affect it. There's nothing really to distribute. The plus sign doesn't affect it in any way. So that's why I just rewrote them exactly as I saw them here. I had negative 5x squared. I wrote it as negative 5x squared. I had negative 2x, and then positive 3, positive 3. Okay? It's only when we have a negative out in front that we need to worry about distributing the negative. So let's go ahead and combine these terms that we determined like. So we have 3 minus 5. We're going to combine the numbers out in front. 3 minus 5 is 2. And then we're going to keep the term, the variable, I mean. Here we have negative, negative. It's going to be negative. 4 and 2 gives us 6. We're going to keep the variable. And then we have 10 plus 3, which is just 13. Nothing else I combine, so that is our final resort, written in standard form because it's descending in degree. Here we have another one. We have 4x to the 4th. We're looking for any other x fourths. And there it is. Here we have an x squared. The only other x squared is here. And then we don't have another constant. And look here, we don't have any other ones, negative ones, or any numbers. We don't have any other x cubes, and we don't have any x's by themselves. So the only things we can combine, 4x to the 4th, negative x squared plus x squared, and then all these are by themselves. So 5x cubed, whoops, a little sloppy, 5x cubed minus 2x minus 1. Okay, so we do, let's combine what we can combine. We have 4x to the 4th. Oops, I forgot to include the positive x to the 4th, plus x to the 4th. There we go. So we get 5x to the 4th. Because this is a plus, we don't change any of these. 5x to the 4th, done with those. We have negative x squared plus x squared. Those are going to cancel completely. So then we just have plus 5x cubed minus 2x minus 1. We need to make sure this is in descending order, and it is. Moving on to subtraction, almost exactly the same. Just keep in mind, if you have a minus sign outside of parentheses, we need to distribute this minus sign first, and then it's just essentially combining like terms. So we have 6x squared minus 7. We just copy that down. Then we have minus. We distribute that to positive 2x squared. We get negative 2x squared plus 3. So now we have 6x squared minus 2x squared gives us 4x squared. Negative 7 plus 3 gives us negative 4. And then we're done. Okay, this is essentially combining like terms, but this is polynomial, so this is just kind of the next step up from what we've been doing before. Again, a minus out in front, we need to distribute that minus to all three terms, 1, 2, 3. Copy down the original, the one in front, 3x to the 4th, minus 3x plus 5, minus 2x cubed, minus 3x, minus minus becomes plus 5. We're going to look for anywhere where there's like terms. There's no other 3x to the 4th. There's no other x cubed, but there's an x here. There's a 5 here and a 5 here. So we get 3x to the 4th minus 2x cubed. Those ones were by themselves, so we're just going to leave them, and they're in descending order. We went from the highest to the lowest. Now we have the no x squareds, so we're going to go ahead and skip down to x. So we have negative 3x minus 3x. That gives us negative 6x. And then we have positive 5 plus positive 5. That gives us a positive 10. And there's our final answer. Stay tuned to next time when we talk about multiplying and factoring monomials with polynomials. Until then, be good, be kind, be true, be nice, and be honest.